Good morning, everybody. Thank you for joining this talk. So just by a quick show of hands, how many people think that data requirements are going up and not down? Okay, so this is a perfect spot for this conversation. So we are, I'm with Fusion.io, and we're excited to be here. We've had a lot of great success in terms of accelerating enterprise applications. And so we're really appreciative of how we've been able to serve our communities and the adoption that we've had in the industry. And on a personal note, one of the interesting things is that Monday through Wednesday of this week, I spent some time in arguably the most expensive bed and breakfast in Palo Alto, Stanford Hospital. And one of the interesting things that happened while I was there was two lab technicians came around for a blood draw. And one of the lab technicians turned to the other one and said, "Do you want to try it out on this one?" And that's not one of the things that you want to hear from somebody when you're on a hospital. You don't want to be the guinea pig. So that's why it's really nice to know that there are real world results that are very applicable here in terms of combining Fusion.io and CouchConf. So here's an example of a very large mobile gaming company. And you can clearly see how they went from the problem to the solution and the results. So in their initial space, they had 4 Couchbase databases, and they were really having a lot of struggles with backups and having a good RPO. And they were experiencing 36 hours, and every single time that they do that, they'd have to do it in serial. It'd impact their production systems. And they would only be current every 6 days. And so the solution was really putting in Fusion.io drives, and the result was dropping those backup times down to 15 minutes. So that's a fairly compelling performance improvement when you're talking about going from 36 hours to 15 minutes. You're talking about a 576 times performance improvement. So when you look at the real value from a customer standpoint, you've got higher performance. So the databases are running much faster because they're not being impacted by the backup production systems. You've got better SLAs, you've got more frequent backups, and you're in a much better situation. So we're going to really focus on how ultra-low latency systems and components as a whole really impact architectures like NoSQL architectures. And we're going to go over ioMemory, which is our core Fusion.io product, and we're going to also look at derivative products like Ion, Partner Solutions, ioTurbine, and then also some of the future architectures that we're looking at based on what Couchbase is doing with their Couchbase server and native SDK access to ioMemory. So let's look at how this starts off in terms of being useful and applicable. So the big challenge in data centers today is really the gap between storage and compute. So basically compute has really taken off, but memory has not really kept up. And so what you have is you've got server utilization 15, 20%, 25% in these really constrained situations. And you've got AMD and Intel having done a great job of not just accelerating individual cores, but actually even adding more cores and more compute to the systems. So the high core counts are unexploited. And so now what we do is we really enable acceleration by adding ioMemory. And so ioMemory at its base level is a standard PCIe card. You simply plug the card into the server. It supports pretty much any 64-bit operating system. So Windows, ESX, pretty much any flavor of Linux, and architectures like Solaris and FreeBSD coming soon. And it's a very highly reliable product as well. So it's been proven in mission-critical deployments, and we've got hundreds of petabytes deployed. And so we're really able to say that you can really put the performance of a SAN in the palm of your hand, because you're able to deliver what would conventionally take a very large specialized disk array into a fairly tight form factor. And that really changes things, because you're able to now deliver data in microseconds. So just imagine in that earlier picture where we saw all those cores and CPUs waiting around. It's just like having a call center with 16 people inside the call center with only one inbound phone line. Not a whole lot of work gets done. But if you give everybody their own phone line, you can get data to all the cores, you unlock the performance headroom of the entire system, and all of a sudden everyone can take a call, everyone can do work, and a lot of work starts to happen. And that's really the basic combination of how things work here. So now we're putting flash really at a high performance tier on the PCIe bus at microsecond access. And then what people are able to also do is rebalance their system. So they don't need to really put a ton of RAM, because one of the things that they find out is that if you put a ton of RAM, that makes your L1, L2, and L3 cache actually less effective, because you're constantly blowing those out. So by having a nice balanced system here, you're really able to create a great performing system. But one of the things is you notice is there's this access delay between here and the SAN, and this is the original thing that we pushed in terms of how much better we were just being in the local storage. But this is also being challenged now, and this paradigm is falling apart pretty quickly, because if you look at what our partners in the networking world have done, and you look at what people can do with network fabrics, it's really latency that matters. It's not just throughput. So if you look at the giant latency improvements in terms of Ethernet, fiber channel, InfiniBand's always been fast, but the key thing is you no longer need to go to an exotic fabric to get these big latency improvements. And a lot of people, when they look at networking, they tend to focus on the throughput. They tend to look at that, okay, my actual need is under a one gigabyte roof, so I don't need to go to 10 gigabits. Or in my fiber channel case, I'm only pushing two or 4 gigabits. I can just add another link if I want that. But that's actually not the case, because if you look at what's going on as you improve these fabrics, the latencies are dramatically lower when you go from 1 to 10 gigabit. They're dramatically lower when you go to the latest generation of 16 gigabit fiber channel, even running at the lower speeds. So it's really important to keep that in mind, because you want to have ultra low latency designed in throughout your entire infrastructure. And so here's an example of a decentralized I/O architecture, where if you just go ahead and you just add these individual cards in, you have a low latency network. What happens is it's just as fast to get the data across the network as it is to pretty much get data inside the network. And that's where it's really a game changer when you're looking at ultra low latency, high performance scale out architectures. So now we talked about the fabric. Now let's go ahead and talk about some of the shared storage components. So in terms of block, we have this product called Ion. So we talked about the ioMemory. Well, what we've done is we've taken ioMemory and we've put it inside of a system. We've developed this solution called Ion. We'll get a little bit more into that later. But the key thing is it's now a shared storage target. So it can service InfiniBand, Fiber Channel, and iSCSI. And then we've got partners who have pretty much done the same thing. They've taken the same base ioMemory component, companies like Common-Ario and NextGen, and they've developed full-featured SANs. So they no longer have to have a large, specialized disk array. They can just go ahead, use ioMemory, put on a fast fabric, and then deliver the performance through software. So the new paradigm is really shifted. We're no longer in the milliseconds out here. You can get excellent performance inside the server, but you could also get excellent performance as you go to an external storage array. So let's look at bringing the pieces together now. So how do these pieces all fit in terms of a caching layer? So here is a picture you should probably be all familiar with, because it's right off of Couchbase. And so they're looking at how you can go from a Membase architecture to a Couchbase cluster. And so we're going to look at how we can slide Fusion IO into accelerating all of those tiers. So you can go ahead and put ioMemory directly into the individual servers, and that'll get that performance bump right there. And then on the back end, even with your RDBMS for cache misses, that's also very painless now as well, because you can go ahead and have that MySQL database riding on top of ioMemory directly, or depending on how that's set up, you could have it go and hit one of these high-performance storage arrays on the back end, depending upon your needs. So it's really easy to put these pieces together in a way that really accelerates the whole infrastructure. And so here are the ultra-low latency wins that you get out of that, because all of these pieces that you need, from replication, disk flushes, and access inside of something like a Couchbase infrastructure, those all happen much more quickly. Also, cache misses are inexpensive. And so you can now start turning how you think about designing your system completely on its head. All these ideas like, okay, I have to try to have everything fit in RAM, because if I don't have everything fit in RAM, things are going to be falling apart on me because of cache misses. So that's completely gone out. Go ahead and and start disrespecting all of these paradigms. Start shoving a lot more data into your caching tier, because now if you overflow, the infrastructure can completely handle it. And one of the interesting things that people have found is it not only is the infrastructure changed, but the way they engineer has changed quite a bit, because a lot of times it's with these wonderful tools that companies like Couchbase have put together, it's fairly fast to prototype something and put it out there. But it's very time consuming to optimize it for web scale, because I can code something up and it'll be there and I can have 10 people log on it today. But if I expect 100,000 people to hit it properly, forget it. It's not going to happen. It's going to keel over. So there's a lot more time and energy spent in terms of scaling out the infrastructure, figuring out how to handle web scale loads. And so that's also dissolving, because now that the infrastructure can handle it, it's very compelling for companies to start adopting these ultra-low latency technologies, because the infrastructure now scales to handle the load, and so engineers can go back to quickly creating concepts, putting them quickly into production, and then all of a sudden that production can just scale. And so it's really what's driving a lot of people to look at their TCO, not just in terms of things like footprint, dollars per watt, dollars per queries per second, the different metrics that people would use at the application level to evaluate the system. They're also able to look at how they're monetizing their engineering time and stuff like that, because these are very compelling rationale at the business level to start looking at these technologies. And then also when you look at deploying things in virtualized environments, things are even more complicated. There are more moving parts, and you have different pieces in contention for services and resources. And so Fusion IO works very well in virtualized environments. So with Hyper-V, KVM, ESX, we plug right in there and we can work very well. Citrix will be coming soon with 64-bit support. We need a 64-bit OS to function, and so once that's available from them, we're really excited to have that available as well. And we also have caching components. So we have caching on ESX with this product called ioTurbine, which I'm going to describe right now, where you can actually use your existing SAN, so in case you don't want to replace that wholesale, but you just want to do something like a cache offload in a virtual environment, that's a great solution for that. And the way ioTurbine works is that basically you simply plug the cards into your virtualization layer, and then it does what's called a read offload. So it currently works with ESX, and it fully supports Windows, and we're going to have Red Hat be GA'd, support for Red Hat GA'd fairly soon. And basically what it does is it works as an intelligent cache. So it's a write around cache for data you don't want to have cached, and it's a write through cache for data you want to keep hot. So it's very effective at making sure that the cache is not blown out. So everything's always, of course, committed to the SAN back end, but most of the reads are served hot right away. So read requests are not hitting that back end. And so this works very well with existing SAN and NAS architectures. And one of the things that we talked about in the beginning was how Couchbase was looking at more interesting integration with Fusion IO. And this is where our SDK becomes quite interesting. So with Fusion IO, in addition to the ioMemory technologies that we have a fairly sophisticated SDK that's going to be coming online in GA soon. And so what it does is it allows faster access and a persistent tier. And so what this translates to you in practical terms is simply more options for lower latency access to ioMemory. So the standard mechanism is that of a block device. So if you go ahead, plug it into a Windows system, it'll be like C:, D:. If you plug it into Linux, you'll go ahead and mount it like a regular mount point. That's the standard way of doing it. That's how people have always integrated ioMemory. Now with these advanced SDK options, you can go ahead and access the flash at a much more native level. We've got things like atomic writes, we've got things like auto commit, we've got things like key value pairs. So if you have something like atomic write, it's really beneficial if you're like a database vendor. You don't have to go ahead and do double buffering to make sure that things were committed accurately to the system. So Fusion IO goes ahead, does that, commits it, and you don't have a torn write scenario. And what's also very nice about something like this is when you look at technologies like Couchbase, when you're operating always in the RAM tier, one of the challenges is that if you have to bring down the system and bring it back up, RAM is inherently a non-volatile medium. So your entire cache is completely cold, and it's painful to restart like that. Whereas Flash, it's completely persistent. You could leave it off for hours, you could leave it off for days, weeks, etc. That's not a problem. So what's nice is when you bring these systems back up, or if you have to reboot or recycle a system, do some maintenance, etc., you can keep everything persistent as you need to. And so all of these, what's nice, the other thing that's nice is that you don't have to worry about this in terms of what you're doing. Couchbase is doing the heavy lifting and doing that integration. But it's great to know that your existing investment in Couchbase and Fusion IO is only going to get much, much better and more exciting. So the key paradigm that we've been really working along here, in addition to ultra-low latency, is software-defined storage. So in every example that I've given so far, we've had direct attached storage solutions, we've had caching solutions, we've had shared storage solutions, but in each one of these contexts, we've simply been able to use the same standard ioMemory and then connect that with the appropriate level of software to really define how things are going to be used. And that's really a big break from traditional requirements, because in the past, one of the big benefits was the large array vendors. They did a great job creating all sorts of specialized controllers, firmware, hardware management components to manage these massive arrays of disk drives and handle fault tolerance. But that was also a technical moat for them. So now, when we're able to introduce this high performance tier of ioMemory, that's not really required. Software companies like Couchbase and others can go ahead and simply use these ioMemory components and have it do exactly what they need to, and performance is a given. So you can go ahead and take the same high performance fabric, network fabric, high performance memory components of ioMemory, and simply turn an existing standardized low cost server into a shared storage target. It could be a caching tier, it could be whatever you want to be, and it's very flexible according to your evolving infrastructure requirements. So here's the ioMemory platform in terms of its various flavors. So we've got capacities from the hundreds of gigabytes to multiple terabytes, and we deliver microsecond latencies and hundreds of thousands of IOPS. In terms of Ion Data Accelerator, it's a package which installs onto a commodity server and turns that into a high-performance LUN, and additional features are quickly being integrated into it as well. But once again, it's just involves the management tier, and you can take any standardized server, Dell, HP, IBM, Supermicro, etc., and create this according to your requirements. So we're really excited because we feel we're really accelerating the enterprise. We can apply ourselves in a lot of great places, and Couchbase is an excellent partner for working with this. And we've been adopted in a variety of spaces, from databases to security logging to big data analytics. So it's been really exciting in terms of what people have done in innovative ways with this new high performance storage tier. And we've had a lot of different customer success stories. You can see them all on the web. We've got about 30 plus case studies, and it's all detailed for you online. And what's really nice about these case studies is they don't get into the weeds of the IOPS and the latency so much as the improvements at the customer level. And that's really what's meaningful to folks today, because when you look at where business moves in terms of today's economy, they really want to make sure that there's value at better SLAs, better application performance, being able to handle more queries per second. So all of that's very exciting, and we've got that all up for you here. So that's pretty much the contents of my talk today. So does anybody have any questions or requests regarding this information? and how ultra-low latency can impact your architectures. Anybody? Okay, so we actually support pretty much every flavor of ioMemory, and I do want to clarify that. It's only in the case of ioTurbine where you have certain guest VMs inside of ESX, and you want to make sure that those are accelerated. We support Windows, and we support Red Hat in the near future. But other than that, we support pretty much every flavor of Linux that's out there, from Red Hat, SLES, CentOS, Ubuntu, you name it, it's pretty much on our website. Fantastic. Oh, so the question was, what is the integration path for Couchbase and Fusion.io in terms of directly accessing the key value API? So that's aggressively in progress. So we're probably going to have more data to share regarding that soon. One of the key points for Fusion.io is high reliability. So with Where, we have a couple of different key features that offset some of the challenges with Flash. So there's traditional things like wear leveling to make sure there's an even distribution of writes across the card. But there are also other technologies for data recovery. So in case there's something like a bit flip, we've got very deep ECC. So it's pretty easy to go ahead and recover data in case something goes wrong. But also we've got a very key feature called adaptive flashback. So each card is over provisioned. So what that means is that if you see something like 320 gigabytes of flash, that's usable capacity, that's what you'll see when you install the card. But what's actually on the drive is about 400 gigabytes of raw flash. And so what we're able to do is, in case something goes bad in terms of, say, a die failure, and the physical die actually goes bad, then we're able to completely recover that data due to the information being backed up in other locations, and then we're able to reprovision another die to be a backup. So we're always in this N+1 state as well throughout the card. So all our management tools have the ability to do that, and there are different ways to hook in to that information. So you can simply do it. Some people just screen scrape from the command lines, but other people want to programmatically access it through some of our APIs at the through the management SDK. And so each card has like a life in terms of, if you imagine petabytes written as being the equivalent of tread wear on a tire, you can easily monitor and see how much use you've had, if there's any alerts that the card has, or if there's any abnormal use of the over-provisioning space. All that information is available.
Is that the new SDK that's coming out? Or is that
No, there's actually an existing management SDK that allows that. So that's pretty much been in place for quite a while. But most people, they just find it's just as easy to screen scrape, so we get a lot of people doing that. Okay, so the question was, at what point does the RAM imbalance impact L1, L2, L3 cache? So earlier I had mentioned that if your RAM size is too big, it's gonna impact your L1, L2, L3 cache. It depends on the access pattern. That's always gonna have an impact. And so, so we found that effects happen quite quickly. So you can have big impacts just even going above 32 gigs of RAM. But once again, it depends completely on your access pattern, because if you've got a certain distribution on a small RAM set, you can always be blowing out your L1, L2, L3 cache. But you're almost always going to do that as you increase your RAM. So we've gotten calls a lot of times from partners saying, I don't get it. Like I had a call the other day with a partner working on a database deployment with our card, and they were trying to optimize it. And they asked me, okay, how did this happen? We just had 32 gigs in the system. We bumped it up to 96, and the performance dropped like a rock. And when we analyzed it, we think it was due to that situation.
Well, what's the workaround for that? It's pretty common to have more than 32 gigs.
Yeah, so it totally depends on your situation. The key point is that you no longer have to feel that it's the maximum RAM that's going to get me to where I need to go. The key point is what's the right balance of RAM, what's the right balance of Fusion, what's the right balance of all these components. That's really what it boils down to. It's not simply more is better. Okay. Okay, well, once again, my name is Jamila. I'm with Fusion.io. If you've got any questions, you can email myself, or if you're ready to buy, go ahead and contact sales@fusionio.com. But we're very excited about what Couchbase is doing, and we're very excited to present here with them. So thank you all very much.